Alright, ladies and gentlemen, this is going to be the next video on water and polarity, and what we're going through and understanding here is we're going to be looking at water as a solvent. Let's get started on this next video. Alright, so what we need to do is we need to understand the hierarchy of a few things. We need to understand what the atom is. An atom is a basic unit of a chemical element, and atoms are going to come together to form molecules. So in the case of water, water is a combination of two hydrogens and one oxygen, and a molecule is a group of atoms bonded together. Now lastly here, we need to understand what a mixture is. A mixture is made up of two or more different chemical substances. We can see that in the diagram to the right. What we see is we see multiple molecules mixed together in the same substance. So when we think about a mixture is a material made up of two or more different chemical substances. An example of that, cookies are an example. Chocolate chip or M&M cookies are an example of a mixture. Chocolate milk might be an example of a mixture. Chemical cleaners are also going to be an example of a mixture. And it's important that we understand what a mixture is, because when we're talking about water, water doesn't just exist by itself. It's going to exist in our blood and along organisms, and usually in a mixture. So what we're going to be looking at here is we're going to be looking at a few vocabulary terms that are key for the rest of the year. If we were to take salt and put it into a glass of fresh water, we need to understand some vocabulary. Now the first vocabulary word that we need to understand, a solution is a liquid mixture that is the combination of a solvent and a solute. Now what is this solute? Well, the solute is what is being dissolved. So in this case is going to be the salt. The solvent is what is doing the dissolving. So in the case of the saltwater mixture, the solvent is going to be the water. These three vocabulary words are key for the rest of biology, and it's important that we understand the difference between a solution, solute, and solvent. Now another key concept that we need to understand is polar substances are going to dissolve polar substances. So molecules with partial charges will dissolve other molecules with partial charges. Polar is going to dissolve polar. Likes dissolve likes. Now on the contrary, nonpolar is going to dissolve nonpolar. So if we look at this, molecules without partial charges will dissolve other molecules without partial charges. That's going to be our nonpolar to nonpolar molecules. So you might be thinking, Mr. Sam, what is going to happen if I have unlike charges? Well, in the case of unlike charges, polar and nonpolar molecules will not mix because of the difference in the charges. So if we go through and we put oil on top of a water solution, what we're going to see is they are not going to mix, and they're going to form distinct layers. The water molecules are polar, which means that they have distinct charges, and what we can see is the oil is not going to have that same charge. We have a polar and a nonpolar substance, so because of that, what we see is these unlike charges are going to not mix. Now, the key to remembering this, likes dissolve likes. If they are not the same charge, or if they are two substances, one is charged and one is uncharged, they are not going to mix. That's going to be what we see in the case of water and oil. So let's go through and look back at our water and salt example here. What we can do is we can make some assumptions knowing that water is polar, whether or not salt is polar. Now what we know about salt is going to go through and be bonded by an ionic bond. We don't really have to understand that other than ionic bonds, we are giving and taking electrons. So what happens when salt is dissolved? What's going to happen is the sodium and the potassium, those two charges are going to go through and separate. What we see is they're going to go through and attach themselves to the charges on the water molecules. When that happens, the process of dissolving occurs because we have a partially charged molecule, the water, with a partially charged molecule, the salt. So they are going to dissolve each other because of these partial charges that exist amongst the atoms and the overall molecules. Now what we can do is we can categorize different molecules based on their relation and attractiveness to water. So let's look at the word hydrophilic. In a hydrophilic substance, it's a substance that is attracted to water. It's attracted because it's also a polar molecule. Hydro means water, philic means loving, so hydrophilic put together means a substance that is attracted to water. On the contrary, what we're going to see is a substance that repels water or is afraid of water is going to be a nonpolar molecule. Again, hydro means water, and phobic means to be afraid. So substances that are hydrophobic are going to go through and repel water. So if we're looking at this, hydrophilic, this is going to be water that is pulled inward towards the glass. So if we go through and look at water on a glass slide, what we can see is the water is going to be pulled inward, and we're going to see that it's going to be generally flatter. The angle is going to be less than 90 degrees if we put water on a glass slide because the glass slide is polar. Contrary to this, if we put the water on something that is non-polar, or we put it on glass that's coated with a little bit of oil, we're going to see the water is pushed away. If we put a hydrophobic substance across that slide, what we see is the angle is going to change. It's going to be between 150 and 180 degrees, and what we can see is we're going to have a more bubble-like or more round-like water. So in hydrophobic substances, it's repelling water and it's pushing the water away from that surface. Now we also need to understand mixtures. A homogeneous mixture is going to be one in which one substance is dissolved in another. And in homogeneous mixtures, we see uniform distribution. This is like when two like charges, either polar to polar or non-polar to non-polar, combine. Now in the case of a heterogeneous mixture, this is a mixture of water and non-dissolved materials. We see non-uniform distribution. And this is because we have unlike charges. This is when two unlike charges, either polar to nonpolar or polar and nonpolar, go through and combine. Heterogeneous, we see non-uniform distribution. Homogeneous, we are going to see uniform distribution based on the charges of the molecules in the mixture. Alright, so there was a lot of information in this video, but we want to learn a couple of key things. We want to learn what a mixture is, and we want to understand how mixtures are affected by polarity. Likes dissolve likes. Polar is going to dissolve polar. Non-polar is going to dissolve non-polar. And unlike charges are not going to mix. That's like oil and water. And what we really want to understand is what it means for water to be polar and how it acts as a universal solvent for dissolving other things within mixtures. This is going to be the end of the video. I will see you all in class tomorrow.